Welcome, everybody. We'll begin the virtual office hours in just a minute, and we'll go over the assignment, my assignment solution for programming assignment number 2 during the office hours. If you join and can hear me, I'd appreciate if you just let me know that by typing it into the question bar so I can make sure that people can hear what I'm talking about. Thanks. We'll start shortly. All right. Okay, great. So it looks like we got some people logged in, and it sounds like they can hear. So let's go ahead and get started. Welcome to the next virtual office hours for the POSA Concurrency MOOC. What we're going to do today is I'm going to walk through my solution to programming assignment number 2, which you'll be starting the peer assessment on here shortly, or if you haven't already started. And I'll show you 2 solutions. I'll first show you the one to the shells that were given out before, and then I'll also show you a solution that fixes one of the problems that was reported that we'll talk about in just a minute. Okay, so let us go ahead and bring up the slides, or rather bring up the program. So hopefully you can see the Emacs window that's sitting up here. This is going to be the discussion of my solution to programming assignment number 2. Remember that someone doesn't have to have a solution exactly like mine in order to get full credit, but it should be somewhere along these lines. And of course, if you have any questions, don't hesitate to ask, and I'll be happy to answer them. So let's go down in here to the structure of the overall source code directories. This, as usual, follows the model view presenter pattern. As you can see here, we have the MVP file that has the required interfaces. These are the ones that get called back by the presenter layer to the view layer to tell it to do certain things, to display certain kinds of information visually to the user. We also have various interfaces that are provided up, or various methods that are provided up from the presenter layer to the view layer. Things like start and checking whether things are running and so on. And there's also some things that are provided by the model layer to the presenter layer. And this is basically stuff having to do with managing access to the Palantir. Okay, so that's just a quick summary of that. Let's go over here and we'll look at the presenter layer first. So there's a couple of places you have to fill stuff in. Let's go ahead and look at the to-do instructions. So the first thing you had to do was figure out how to create a new thread. And this is what, of course, is going to be used by the thread pool executor that's going to actually be running the various async tasks. And we have to create a separate thread here and a particular kind of thread because of the interesting interactions between the various layers in the MVP pattern. In particular, we want to be able to interrupt or shut down a being thread, and that being thread has to have some way of being shut down. And so we'll take a look very briefly to see how that works. But that was not part of what you had to implement. That was brought over from assignment number 1. So of course, what you have to do here is you have to make a new being thread. You have to pass in the runnable, which is the method that's, or the parameter that's passed to new thread. You pass in the runnable. You increment the being count by 1. Since it's an atomic integer, that'll always give you a unique value. And then you simply pass in the Palantir presenter object, which is essentially the class that's enclosing this thread factory. You pass that in, to the being thread. So the being thread has a way of being able to get back to the palletary presenter in order to do certain things to interact with it. Okay, so that's how you make the new being thread. The next thing you have to be able to do is shut down, be able to cancel the tasks. And I can't remember whether I gave this as part of the assignment or not, but if I gave it as an assignment, this is basically what you have to do. You just have to iterate through all the tasks and tell each async task to cancel itself. And the parameter that's passed in here that's true just indicates that you want the task to be shut down right away. So that'll stop things from running in the background. Here's the create and execute beings tasks method. This is the method that gets called here from the start method. So when start gets called, it goes ahead and joins the being, it calls a method to join the being task. We'll look at that just for kicks. And then it calls create and execute being tasks. Here's the join being tasks method. This goes ahead and makes a new countdown latch, which we're going to use as an exit barrier to wait for all the being tasks to stop their gazing. And then we're going to create a new thread in here. And this thread will run in the background, and it'll basically wait for all the other being tasks to be finished. And when it's done, then we tell the UI thread that the simulation is done so it can shut down. That code was given to you. Here's the code you had to write, create and execute being tasks. So here you go ahead and create an array list of being tasks, which in this case are being async tasks. We'll take a look at them in a second. And then you iterate through the number of being counts from 0 to 1 less than the being count. And you go ahead and you create a new being async task object. We'll look at that in a second. And you pass in the index so you can distinguish one from another. And you also pass in the exit barrier, which will be used when the task is done. We add those tasks to the list of being tasks, each one of them. We then come down here and we create a thread pool executor. And we have to make sure that the being count for this is, or rather the number of threads that are the core threads and the max threads are the same number, and they both have to be the being count, because we want to have a thread in the pool for every one of the beings that can gaze, and that way we ensure that they all get a chance to run and can block without causing problems. We give a 0 as the timeout, and that just says don't time anything out. We create a new linked blocking queue, which is going to hold runnables, and we create a new thread factory. There are other values you can give here besides 0, but 0 worked fine for what I was doing, so that's what I did it, why I did it. And then we pass in our thread factory, and so we have a new thread pool executor, and the thread pool executor will then be used when we call execute on executor for each of the being async tasks. So what we're doing here is we're going to iterate through the list of async tasks, and for each one of them, we're going to execute the async task on this thread pool executor, and we're going to pass in the palletary presenter object, this, as the presenter layer object to the being async task, so it can reach back up into the presenter as necessary to do various kinds of things. So those are basically the steps that we want to be able to do here. You can see it's very straightforward. It's very canonical. This is taking async task to the next level by creating a thread pool executor and then using that thread pool executor in a specialized way to run the async tasks. So it's going above and beyond what you would often do with an async task, just to demonstrate how you can do more powerful things with async tasks. Okay, so that's basically what there was in palletary presenter. Let's now go over here and look at being async tasks. That's the other thing you have to implement. This extends async task. It's going to pass in a palletary presenter, and it's going to have a runnable, which is going to be used to communicate from the background thread to the user interface thread. And there is no return value here. I couldn't think of a way to use one, so I just made it void. Here's the implementation. We keep track of the beings index in the list, which is used to differentiate one being from another, mostly for purposes of debugging. Here's the countdown latch, which we have access to. We pass that in to the constructor of the async task. And then, as you can see here, And actually, we could get to this countdown latch other ways. I just did it this way. That's not the only way to do it, of course. And then here's the do in background method. When execute is called, that's going to pass in the Palantir presenter. And again, that's not the only way we could have done it. I'm just doing it to illustrate how async tasks work. And we're going to pause for a few, half a second basically. And then we're going to go into the main loop. And this loop is going to keep iterating until it's either done with its gazing iterations for this being, or the application has been told to shut down the simulation. The simulation is shut down if the task is canceled. So if is canceled returns true, then we go ahead and shut down and break out. We'll talk more about that in a second. Then there's a bunch of methods, and they're all done exactly the same way, just with different runnables. There's a whole bunch of places where we want this do in background method, which is running in a background thread, to be able to communicate information to the user interface thread to tell it to update the display, basically to give the twinkling dots of the different colors depending on what state the simulation is in for each being in each Palantir. So we start off, for example, by publishing progress, and we say, hey, presenter, get me the view, and then tell the view to give me back a runnable that's marked for waiting, and then send that runnable to the UI thread by calling publish progress. And that's all there is to it. This was just in there to demonstrate how you can talk from a background thread in an async task to the UI thread. You might or might not actually choose to do this in a real program. If you look at programming assignment number 1, you'll see an alternative way of doing this using the Hammer framework. This uses the async task framework just to illustrate how this works. We then go ahead and acquire a Palantir, which could block if there's none available. And then we go ahead and do a little bit of bookkeeping. And we change the Palantir to be used. So we go ahead and set the Palantir to be basically red. And then we mark the being as gazing, which will turn it green. And then the Palantir goes ahead and starts to gaze. And it'll gaze for some random amount of time between 1 and 5 seconds. And then when it's done, we go ahead and say, hey, we're no longer gazing anymore. We're now idle. And once again, we create the appropriate runnable and pass it to publish progress. And here we mark the Palantir as being free, which makes it green. And then we tell our bookkeeping count that we are done, just so it'll decrement the count by 1. If something goes wrong, we shut down, and then we finally give back the Palantir to the manager, no matter what. Now, as you can see, if you're shut down, you break out of this thing, then the Palantir that you have will actually be it could be null in that particular case. And so in that particular case, this will just go ahead and do nothing. So releasing a Palantir that's not being used is sort of a no-op, so that's fine. Okay, then down here, when we're all finished, we drop out of the loop and we return null. Here is on progress update. This is what gets called back when publish progress is invoked. And as you can see here, what publish progress does is it goes ahead and simply calls the run method on the runnable that's passed in. So nothing could be easier, right? This is super duper easy. We've taken a runnable created in the background thread and we've passed it to the foreground thread by using publish progress. And then that causes the on progress update method to be called back. And when on progress update is called back, we simply take the runnable and say run. And that works fine because at that point we're in the user interface thread. And so we just have to run this command. And that'll go ahead and run the runnable, which will update the user interface. And if you take a look at the activity, the gazing simulation activity, you'll see what it does. After doing background is finished, if it finishes successfully, on post execute is called, and we just decrement the exit barrier by 1. If things are canceled, then we go ahead and decrement the exit barrier by 1. So as you can see here, no matter what we do, the exit barrier is getting decremented by 1, and that way we know that this task is finished, and that will be used to control the shutdown in the simulation. All right. And then these are just some bookkeeping methods that I gave you that use atomic integers under the hood. Okay, so that's pretty much what there was from the Palantiri manager perspective. As you can see, it's actually quite simple, but it's really trying to show how the various features work with the underlying support that's there for async tasks and how various hook methods get called back and move information back and forth between various threads. Let's take a look now at the model layer. This is where we actually interact with the underlying set of Palantir and Palantiri, and that's done by something called the Palantiri manager. Palantiri manager keeps a semaphore that's going to keep track of the number of threads that can run concurrently. And then we're also going to have a concurrent hash map, and this concurrent hash map is going to be used to map a Palantir to a Boolean that indicates whether it's in use or not. And you'll see how this allows us to not have to have any synchronized blocks in the code. We simply use the features of the concurrent hash map to make everything work right. Here's the constructor for Palantiri manager. We make a new concurrent hash map. We iterate through that map, and we put all of its keys to be true, which means they're available. And then we go ahead and we make ourselves a semaphore that's sized by the number of Palantiri that we've been given, and that's fair. So it serves the threads in round-robin order. Here's the acquire method. As you can see, acquire simply goes ahead and acquires the semaphore uninterruptibly. I think that's pretty much what we had in assignment number 1. But the next part's a little bit different, and this illustrates one of the cool features of the concurrent hash map. And under the hood, the concurrent hash map has all kinds of very fancy data structures that try to avoid locking, and if it does have to lock, it does very, very minimal locking using things like a compare and swap, which are basically virtual machine instructions that interact with underlying hardware mechanisms for being able to very quickly acquire a lock without causing a wait. So this is what's called basically, it could be called wait free or whatever. You're not having to wait, you're not blocking. So what it does here is it iterates and goes ahead, and for each Palantir in the Palantiri map, in other words, all the keys, we go through all the keys, we're going to go ahead and atomically replace true with false. We're going to try to replace true with false, rather. And if that succeeds, then we know we were able to get ourselves that Palantir atomically. So what this function does, this is basically just a fancy variant of compare and swap. It checks to see whether the current value of the Palantir is true, which means it's available for use. And if it is true, it atomically sets it to false. If it's not true, in other words, if it's already in use, then replace will fail and return false. So only if it's able to replace a true value with a false value atomically will it return true. And so this allows us to do this check, and it does not require any additional synchronization. Notice there are no synchronized blocks. There's no reentrant lock. All the locking is done by the magic of replace in the concurrent hash map. And that then returns the Palantir. Here's release. Release is very simple also. We do a little sanity check to make sure that the Palantir hasn't been released already. And then we go in here to the map and we try to atomically, we do atomically set whatever happens to be there in the map to true. So what we're doing here is we're releasing this. And what put does is put actually returns the existing value prior to updating it. So if it's the case that the value that's returned is false, meaning that this thing was in use before, then and only then do we go ahead and release the Palantir. So that's a way of, it's a little sanity check. Now, of course, there's all kinds of other things we could do. We could change this thing so that it would throw an exception or return false or do something else, but I just wanted to keep it simple. But obviously in production code, you might decide to do something different. This is just really illustrating how to use concurrent hash map and how to use a semaphore and how to have basically guarded access by many threads to a smaller limited number of resources. Okay, so that's basically the implementation of Palantir Manager. As you can see, that's pretty simple, and it's kind of cool that by using the magic of the concurrent hash map, there's no need to do any additional synchronization in the code yourself, explicit synchronization. It's all handled for you by the map itself, and you just have to know which methods to call. By the way, it is incorrect to call basically get followed by put, because get and put are two different calls, and they will not, in fact, be atomic. So there's no other way of locking a hash map other than just by calling its methods. And so even though get and put are each atomic, getting and putting by making two calls is not atomic. So instead, we have to use the 3-argument replace method in order to make things work properly. Okay, so that's basically what you had to do for assignment number 2. I think you'll agree once you see it, it's very simple, but the trick in all these assignments is to figure out how to do it in a way that will be correct, and it sometimes takes a while to figure out what the mechanisms are and how they get used and so on and so forth. Okay, so what I'd also like to do, and by the way, if you have any questions, this is a good time to ask them. I also want to show you an alternative solution I came up with, because some people had noticed that when the program started, it wasn't giving the Palantir, you weren't able to see the gray initialized values. It was starting out being red right away. And so I implemented another version to illustrate how to do this properly. And the trick was basically to move the call to run simulation out of the onCreate method. So it's no longer called in onCreate. It's now called in onResume. Run simulation occurs in onResume, and that basically gives a chance to show the initialized versions before we start the simulation running. So you'll see the initialized version where the Palantir color is gray to start out with. That's one thing I did. And then the second thing I did, I went over to the presenter layer, and I added what's called an entry barrier to the being async task. And we'll see where this thing gets set in a minute. And then down here in the do in background method, before the do in background method starts to run, I make all the threads basically start at the same time by making them all call the await method on the entry barrier. So let's go over and take a look and see what the entry barrier looks like. So here's the entry barrier. The entry barrier is actually what's called a cyclic barrier. And a cyclic barrier is pretty cool because it can be used to ensure that all the background threads start running at exactly the same time. And so what we're going to do here is, down here in the code, we're going to make ourselves a cyclic barrier that will start out with the number of beings plus 1. And then the cyclic barrier is going to be passed into the being async task constructor. So all the beings, when they start to gaze, will all call that cyclic barrier first. They'll all stop and wait, and then they all start to run when the waiter thread starts to run. And when this guy starts to run, or actually, really what will happen is when the last one starts, when the last one calls a wait, they all start to run. So this allows all the threads to basically start running at essentially the same time. So that's a good example of a cyclic barrier. I could probably also have used a countdown latch there as well, but I just wanted to use a cyclic barrier just to illustrate what a cyclic barrier can do. So if you were to do this implementation, then you would find that things would be gray at the beginning, and it would look a little bit more obvious that it was starting in an uninitialized state, or was starting in its initialized state. Okay, so that's basically the solution to programming assignment number 2. And so let's go ahead and talk about any questions that you might have. So question number 1, how are we sure that Palantir Manager key set is iterated in the same order by all the threads? So that's a good question. Let's go back over and we'll take a look at the code that's being referenced here, so you'll know what we're talking about. So that code, of course, is actually in the model layer. Come over here, key set. So it actually doesn't matter whether or not these, if they iterate in the same order or not, it doesn't make any difference. Now, I think under the hood, it probably will always iterate in the same order, but it doesn't really matter because these calls here are really what matter. And these calls are simply trying to check to see if any of the Palantiri are available. And remember that there's guaranteed, assuming that you followed the protocol correctly and you've released the, you've called release properly, you know, as long as you call acquire Palantir and release Palantir properly from the application, then you always, and of course, assuming that you have a correct implementation of your Palantiri manager. If both those assumptions hold, which they should, if your program is correct, then there should always be an available Palantir. It doesn't really matter what order that they get done in. So it should be okay. Let's see. In the Palantir Manager acquire method, we can't use an iterator with hash map entry and then use get and set value. Yes, that's correct. So you can't. Let's see. Let me bring this up here. In assignment number 1, you used a synchronized block in order to guard access to the hash map, and so the hash map in that particular case would be locked by the synchronized block. So you could do things like basically iterate through it and use the set value and get value methods on the map entry that was returned for every element that's an element in the Palantir map. In this case, however, those are not atomic operations, and since there's no way to lock things other than by using some external locking mechanism, which we didn't want to do, in this particular case, you can't do that because they would not be atomic. Let's see. Does it make any difference if you create a thread, pass the runnable to it, and then start the thread instead of calling run directly? Does it make any difference if you create a thread, passable runnable to it, and then start the thread? Okay, so I'm not really quite sure what your question is, but you can't, you shouldn't call run directly on a thread. That makes absolutely no sense whatsoever. You do not ever want to call the run method on a thread. That would be just incredibly bad. So what you want to do, of course, is you want to create a thread with a runnable, and there's various ways to do that. As you probably know, you can either subclass from thread and then override run, and so then when you call start, the thread's run method starts. Or you can, as we're doing here, you create a runnable, and then you go ahead and pass the runnable to the thread, and then you create that. So that's another way to do it. But you definitely do not want to call run directly. Maybe I'm not understanding your question though. Are you asking in the on progress update method, would it make sense if you created a thread? If that's the question you're asking, the answer is you absolutely do not want to do that because that defeats the purpose of using the async task to pass a runnable from the background task to the UI thread. Could method references be used in place of the current code passing construct? Could method references be used? So by method references, I'm going to assume when you say method references that you're referring to the Java 8 feature of method references, which are basically like kind of like pointers to member functions in a language like C++. If that's what you're asking, then you could not do that with Android, at least not Android out of the box, because Android, of course, doesn't support method references or lambdas or streams or all the other cool Java 8 features. So I think that's what you're asking. If you're asking something different, please help me understand what the question is. Let's see. Monty asks the question, doesn't concurrent hash map replace return true if the replace happens and false if not? Yes. Concurrent hash map replace returns true if it was in fact able to atomically replace the old value with the new value. And that's what we're using here. Question, if threads go in different order, release might be called when one thread is in the middle of iterating over and already passed the released one, but the third thread might steal the Palantir that was free and get ahead of the first thread. I've never seen that happen, so I don't think it can happen. I would think that they would iterate over these things in a deterministic order, but that's a good question. I've never seen that particular problem happen myself. Okay, so lots of good questions. I see. So the question was about the on-progress update method. So in on-progress update, let me go back and show you this piece of code because it's important to understand this. First and foremost, it's important to try to do something that's fairly simple, that doesn't have a lot of overhead. So here would be where we would do this. Take a look at being async task. Here's do in background, right? So do in background is going to call publish progress, and it's going to pass in a runnable, and that's going to call the on progress update method here. And then the on progress update method simply calls the run method on the runnable. And the reason it can do this, of course, is because it's in the user interface thread. And as you all remember, I'm sure, the user interface thread is something where you can only validly or legitimately access the UI widgets and UI views and other user interface toolkit component objects. Those can only be accessed from the user interface thread. And of course, what we're doing here is we're passing in a runnable that will, when run, will go ahead and update the colors in either the being or the corresponding Palantir. So this has to run in the UI thread. If you try to run it in the background thread, bad things will happen. On progress update runs in the UI thread, so we pass it a runnable command. We simply say run. So there's nothing else you want to do here. You do not want to spawn a thread. That would make no sense at all. Why on earth would you want to spawn a thread? Or that would just be extra overhead. And then call its run method directly. That would make no sense. That would just be additional overhead for no benefit whatsoever. So make sure you don't do that. Make sure you don't start the thread, but instead just call run. All right. So those are basically the answers to assignment number 2. I'll be happy to take any questions that you might have about assignment number 3, if you have any questions about that. That assignment's been out now for a couple days. The way assignment number 3 is going to work is it's going to have a longer period, because you're welcome, if you choose, to write the whole thing from scratch. There's no obligation whatsoever to actually follow the shells. You're not obliged to use the shells I gave out. You can pick and choose from different things we've shown having to do with images. So it's really up to you to what you want to do. So I'll leave that as up to your discretion. And I'm happy to answer any questions you might have about it. There's a bunch of different ways to implement it. One thing you might note is I made a fix to one of the parts in the utils directory, which was causing there to be two images that were stored, and two gray images that were stored. And so I've updated that about a week ago. So if you pull the latest version of the shells, you get that fix. The other thing to note is that the way my little utilities work that I provided with the skeletons, those will first download an image and store it in your local file system. And then I have another method called grayscale filter, which basically makes a copy of the image. And so it doesn't change the original image. So obviously the intent there was not to overwrite the original image unless that's what you really wanted to do, or delete it. So in order to use the shells, if you don't want to have duplicates lying around, one that's the original image, one the grayscale image, just go ahead and delete the image if you don't want it anymore. And so you're welcome to do whatever you want. You can keep it around or not. But you're welcome to to do whatever you'd like. Let's see. There's a question about how the MVP stuff works. So we have actually gone through the MVP framework before. That was done for one of the earlier assignments, but I'll be happy to go through it again quickly if you're interested, because it's kind of fun. Let me go ahead and share my screen here. All right, what we're going to do here is we're going to talk a bit about the model view presenter pattern and how it gets used in the various examples and assignments and so on. So as you probably recall, model view presenter is a very popular pattern that's used widely with Android. There's a bunch of frameworks out there. There's one called Ted Mosby, and there's lots of other ones. If you simply go out there and Google model view presenter, you will get access to more information about the model view presenter pattern. In fact, just for fun, let me go ahead and do that for you. So let's go Google model view presenter, and I will go ahead and share my screen so I can show you what it is we're going to look at. So let's see, let's share model view presenter. Here we go. So if you Google model view presenter, you'll get all kinds of stuff. If you Google model view presenter Android, you'll get a whole bunch of stuff. Lots of good articles about model view presenter. And in general, let's just go back and look at the pattern in general. Here's the pattern. It's a way of organizing your client applications so that you separate out 3 different roles. One role is the view, which is how you either get events from users or you display what the users see. Then there's something called the model, which is really where you access data that's going to be stored persistently. And in some cases, it's actually data that's located on the device. In other cases, it's data that's located across a network. In either case, the model is what's responsible for mediating access to that. And then there's something called a presenter, which is basically the controller, sometimes called the supervising controller, that sits between the view and the model and does all the sort of business logic that's necessary to carry out the application behavior. I like to typically put concurrency related stuff in the presenter layer, although you don't have to. You can put stuff that's concurrent in the model layer too. But for what we've been doing in the POSA concurrency course thus far, we've been primarily putting the concurrency in the presenter layer. So the idea is you keep the view layer very simple. It's just stuff that talks to the UI components, and the model layer, in our particular cases where we interact with things that are either remote, like in the case of accessing images via a web server, or in the case of the Palantiri application, we store the Palantiri in the model layer because it's basically where we're going to store it's kind of the state, if you will, of the program. So that's the basic overall view. Now for Android, and the reason why it's such a popular mechanism in Android is to give you a way of being able to handle certain quirks of Android, like the fact that when you rotate the phone, the activity gets destroyed. And there are other ways, of course, of handling this. There are ways in Android of being able to do all kinds of ways of storing and saving and restoring the state via various means that you can use with retained instances and fragments and all this other good stuff. So that's one way to do it. But I find that to be very tedious and probably somewhat inefficient as well, because you have to keep saving and restoring the state, which gets inconvenient after a while. And it's particularly annoying when you have things that run in threads that have to run for a long period of time, and you don't want to have to stop the threads and restart them whenever a screen rotation occurs. So for that reason, the model view presenter pattern is a big win in the case of Android. All right, so let's stop sharing the overall view of model view presenter, and we'll go back to the little framework I've devised. So I've developed a little framework just to teach this class. It's not something necessarily that I'm not claiming it's the best model view presenter framework in the world. There's certainly other ones that you can have. We've actually got other ones as well, but this one works well enough for our purposes. And what it allows us to do is it allows us to focus primarily on the logic of the applications, and in particular on the concurrency models, without having to get all wrapped around the complexity of model view of trying to deal with Android's concurrency quirks, like screen rotations and things like that. So in the framework, there's a couple of different parts that are particularly relevant. There's a thing called the generic activity, and there's something called generic presenter. Those are the two main parts. The generic activity leverages something called the retained fragment manager. We'll talk about that in a second. That's what's used to keep the state off to the side so that it can automatically be reclaimed and restored as needed as the program is run. So I'll come back and talk about these things very briefly, but I mean, I'll come back in a second and talk about what they do. But they get used in the following ways. So in the view layer, if you have an activity that you want to be able to rotate without having all of its state disappear, the trick is to move that state into the presenter. And then you have to inform the presenter layer when the activity comes and goes. The way we do this, as we do with, say, the gazing simulation activity, we make this activity inherit from generic activity. And we pass in various interfaces that will restrict what the view layer and the activity layer, sorry, the view layer and the presenter layer can see with respect to each other. And we do this just so you don't have to expose all your methods to everybody, only the ones that you selectively want. And that's what the MVP file is, this file up here called MVP. This is defining what methods are available for each of the different parts of the layers. So now you don't have to do this, by the way. You could also just expose everything, but that would be kind of defeating information hiding at some level. So we're only exposing certain things. So with the generic activity, we're going to have the view layer expose its methods that are required by the presenter layer. And then we're also going to have the presenter layer define what methods the view layer gets access to. So this is the one that the presenter layer is going to use. This is the one that the view layer is going to use. And then we pass in the class that we want to be instantiated by the generic activity framework in order to be able to create the presenter object. This is the one object in the presenter layer for this particular activity. All right, so that's basically what's going on there. And then we also say that this activity implements the required view ops. Unfortunately, Java's generic features are rather limited, so we can't do clever things we would do with C++ with traits. So it's slightly more verbose doing it this way than it would be if we were doing C++, where we would have traits. So then down in the onCreate method, we do the normal calls, and then the last thing we do, or one of the last things we do here, is we go ahead and we call the onCreate method on the generic activity framework, and we'll take a look at that in a second. And what that does is it goes ahead and takes the class that we want to have instantiated as the presenter object. That's how we're going to get the presenter created. And then we also take a reference to the view layer, and we join these things together. So let's go take a quick look and see how that's going to work. So here is generic activity framework. Has some documentation that explains how it works. Required view ops, provided presenter ops, and then the presenter type. And what this thing does is it creates an instance of something called the retained fragment manager. This is a very clever little class that I've developed that allows you to automatically figure out whether it's the first time an activity's been created or whether the activity has been destroyed and recreated. And it does this using something called a retained fragment. And the retained fragment manager is just basically a wrapper around the Android retained fragment feature. And so it uses the retained fragment feature of fragments to check to see whether the activity has been created the first time or a subsequent time. And it does that by looking up in the retained fragment. In the fragment manager, it goes and looks up the fragment by tag, and it checks to see whether it's been seen there before. If it's null, it's the first time in, so we have some initialization we have to do. And if it's not null, we do some other stuff. That means it's not the first time in. And there's a bunch more cool stuff in here for putting and setting things in the retained fragment, which can be used to good intent. I'm not going to spend a lot of time on this. Basically, this is just a little wrapper around the retained fragment feature of the Android fragment manager. And the generic activity framework uses a retained fragment manager to keep track of whether or not the activity has been created once or been destroyed and recreated. we make ourselves an instance of the presenter type, and then in the onCreate method, we go ahead and pass in the class of the presenter type and the reference to the view layer, and then we check to see if this is the first time in or not. If this is the first time in, we're going to go ahead and initialize the generic activity fields. If it's not the first time in, that means that this is a screen rotation. It's a second or subsequent time in, and so we reinitialize things, and we'll take a look at that in a second. We have a couple of methods, like there's a method called getPresenter that returns the presenter instance, and it returns it in a way where you can only see the pieces that you're allowed to see. You can get the retained fragment manager if we need it. Here is initialize. Initialize goes ahead and it creates a new instance of the presenter type that we passed in as a class, so that we use this as a factory to make ourselves a new presenter type, and that gets stashed away here. And then we go ahead and we store that presenter instance in the retained fragment manager. We store that instance under the name that the type has. So that's how we go ahead and stick that in there. And of course, the question was, is this code available via Git? Yes, of course this code is available via Git. How could it not be available via Git? This is the solution to programming assignment number 2. So we're just looking at the code. So of course it's all in there. And then what we do here is, if it's the first time in, we call the onCreate method on the presenter instance, passing in the view. And that's basically a sort of a virtual constructor that gets called the first time in. So just to pop up a level here and go look over at the presenter, the onCreate method here, you can see how onCreate gets called with the view, which we stash away, and then we do any initialization that we need to get things up and running. This is basically called one and only one time. So here's the reinitialize method. This gets called if it's the second or subsequent time an activity has been created. And what we do there is we go and we look up in the retained fragment manager to see whether or not we can find the instance, which we ought to be able to. Sometimes weird things happen if you have certain settings about destroying activities, but that's rare. So let's assume, for sake of argument, we find the instance that was squirreled away before. And this time, rather than reinitializing it and calling onCreate, which is only supposed to happen once, we call the onConfigurationChange method. And if you look here, onConfigurationChange, this gets called back every time the activity rotates. So whenever the activity is destroyed and recreated, every time the screen rotates, actually the activity doesn't rotate, the screen rotates, and the activity is destroyed and recreated, this callback is given to give us a reference to the new activity or the new view. And we also set a flag in this particular case to show that a runtime configuration change has occurred. Here's the get activity context. This gets you back the activity context, and then there's also the application context, and those are usable in different ways. So that's basically generic activity, and that's really, really, really helpful, because now we don't have to know or care about how the activities come and go. As long as we put the state in the presenter, that state is automatically preserved even when rotations occur. So that's pretty cool. Now, there's also something else that's worth looking at, which is called generic presenter. So generic activity basically connects the activity in the view layer with the presenter object that's created in the presenter layer. And then we also have something almost identical, which is called the generic presenter. So a Palantiri presenter is a generic presenter, and this does almost exactly the same thing that the generic activity framework does, except it creates the model layer and initializes it. So in this particular case, Palantiri presenter is a generic presenter. It has some methods it's going to provide to the model layer. It has some methods it gets from the model layer. And then we have our Palantiri model, which is the thing that's actually going to implement the model layer. We have to implement the required and provided ops in this case. Then if you look down here, you'll see that the onCreate method for the Palantiri presenter goes ahead and calls up to the onCreate method in the generic presenter object, passing in the Palantiri model and the reference to the Palantiri presenter object. And this works almost equivalently to generic activity, what it's doing is it's going to create a generic presenter, and this guy is going to do very much the same thing. It's going to take the model class that was passed in, make a new instance of the model, store it away, and then it'll call back to the onCreate method on the model instance, which is what's used to create the model in the first place. And if we were to pop over here and look at the model, we would see that the onCreate method in this particular case is a no-op because it's handled through other means. But in general, it could be a place to do construction operations that were important for the model layer. And there's also a way to destroy the model as well. Now, the generic presenter mechanism is much simpler than the generic model because it doesn't have to worry about rotations. So we don't rotate the presenter. We rotate the screen, and that causes the activities in the view layer to get destroyed. So we have to accommodate and handle that in the generic activity framework. But the generic presenter framework doesn't have any of that stuff to deal with. So it's much easier, much simpler. But it has basically the same look and feel. And the nice thing about this is that by following these conventions in the code, it always looks and feels pretty much exactly the same. And it greatly simplifies the handling of screen rotations, number one, and also concurrency, number two. So those are really the reasons for using this. Now, there's other bits and pieces that are part of this little framework. There's this thing called context view, which gives you access to contexts. There's this thing called model ops, which defines the methods that models have to override, on create, on destroy, and so on. And then there's also presenter ops, which are the methods that the presenter layer has to override and handle. And those are all very stylized, so I'm not going to talk much about them. Okay, so hopefully that overview of Git is useful to you. Sorry, overview of Git. Hopefully that overview of the model view presenter pattern is useful to you. All that code, of course, is available. It's been available in all the assignments and all the examples that use the model view presenter. It's been available since day one, everywhere you look. And I'm sure that, as I said before, I'm sure there are much better ways to do this that you could do. In fact, we've written them. We have other ways to do the model view presenter pattern that are much more powerful and extensible. But it also, after a while, it starts to distract from the real purpose of this MOOC, which is to talk about concurrency. I've added these features into the stuff we teach in the MOOC because without explaining these patterns, you end up doing a lot of very ad hoc code to try to handle the quirks of Android in the face of concurrency. And rather than have to walk through hack after hack after hack to try to deal with all the craziness that comes with using concurrency in Android, it turns out to be much easier just to have a little framework that automates this stuff. And then you can either learn the framework or just know how to copy and paste it. But it just makes life a lot easier. So I would recommend, if you're curious about this kind of stuff, feel free to take a look around. If you Google Model View Presenter Android, you'll find out lots more information about this. And so you're certainly welcome to take a look. Feel free to use this as you feel as you see fit. Feel free to extend it, enhance it. If you want to contribute fixes back or enhancements, that would be great, but you're under no obligation to do so. And of course, keep looking around to see what other examples of Model View Presenter are out there. And they're actually building in some cool new features into newer versions of Android. There's a new thing called, I think it's like MVVC or something like that, which is basically trying to add sort of a new layer of data management into Android so that the model becomes smarter and it can handle a lot of stuff that you might otherwise have to program yourself. But we won't talk about that. That's sort of outside the scope of what we're covering here at this point. Okay, so are there any other questions? If so, please feel free to ask them. Otherwise, I will go ahead and create a new video here shortly, and I'll put them up on the screen. We might or might not have a virtual office hours next week. It kind of depends on whether people have a lot of questions about the assignment number 3, but We will certainly have another virtual office hours before the class is over, because I want to go through my solution to assignment number 3. And I'm looking to do some pretty cool things with assignment number 3 solution. If I get inspired, I'm going to create something I call an async task chain, which is basically a little generic framework for providing linked async tasks, where the output of one task serves as the input to the next one. And that, of course, would be a nice little feature to add to support the requirements for assignment number 3, that you first download an image in an async task, and then you filter an image in a different async task. So I'll see if I have enough time to build a little framework that automates that, and then we'll talk about that when I show my solution in about a week and a half or so. Okay, well, it doesn't look like there are any other questions. So in that case, thanks very much for joining, and I will talk to you soon.